today I will be filming my extra credit video for Standard 6B about line integrals. So the first thing I'm going to go over is the course standards for 6B. So the goal was to be able to calculate a scalar line integral along a curve, calculate a vector line integral along a curve, and be able to use a line integral to compute the work done by moving an object along a curve with a given force vector field. So I decided to use a question from one of the quizzes on ELC. So I'll just go right into it. So part A says, evaluate the integral of x ds along the path C with parameterizations r of t equals t comma t squared, and 0 is less than t and t is less than 1. T is greater than 0 and less than 1. And looking right over here, I can automatically see that we're going to be using a scalar line integral because the form is the same. So the first thing I like to do is just to write everything out. So first, f of x, y is equal to x, and I just know this from the equation from the integral. And then r of t is t comma t squared, and I just got that right from the question. So f of r of t is equal to just t. And then the derivative of r of t is 1 comma 2t. And the magnitude of the derivative of r of t is the square root of 1 plus 4t squared. So now we're just going to put that all together. So coming right down here, I just wrote the equation up at the top. The dt got a little cut off, but we know that the integral is going to be from 0 to 1 because those are the parameters they gave us right up here. And so the integral from 0 to 1 of t, which was our f of r of t, so this, dotted with the magnitude of the derivative of r of t, which I put right here. And so after I had this all set up, I realized that I was going to have to use u sub. So my u is 1 plus 4t squared, and then the derivative of that is 8t. And then just to get it something that's equal to t, so we can just plug that in, I got 1/8 du. So I just took that 1/8 out front right here. Sorry about that. And then I just did that derivative, and I ended up getting 1/12 times 5 to the 3/2 minus 1/2. So now going on to part B, it says evaluate the integral of f dr, where f of x, y, z is equal to x squared, y squared, and z squared, and c is parameterized by r of t is equal to 3 sine of t, 3 cosine of t, and t squared. And t is more than 0 and less than pi, or equal to, more than or equal to, or t is more than or equal to 0 and less than or equal to pi. So then I just did the same thing right down here, but for this one I did know that I was going to use the other equation that we have, and the only difference between that is we don't take the derivative of r of t, and we don't take the magnitude. So or actually, that is wrong. Sorry about that. We do take the derivative. We just don't, we don't take the magnitude. Okay, so, I just wrote everything out, and then f of r of t is equal to 9 sine squared of t, 9 cosine squared of t, and t to the 4th. And then the derivative of r of t is equal to 3 cosine t, negative 3 sine t, and 2t. So then I plugged that all in and got 27 sine squared of t cosine of t minus 27 cosine squared of t sine of t plus 2t to the fifth. So now it was time to take the integral of all of this, and we knew it was going to be 0 to pi because it's right up here in the question. And so I decided to split up this integral into the 3 different parts that are divided by the minus and plus signs. So I started off by doing 2t to the fifth because that's just an easy integral, and I got 1 over 3 pi to the sixth. And then for the other two, I had to use u sub. The first one was sine t, and the second one was cosine t. And then for the first integral, I ended up getting 0. For the second integral, I ended up getting negative 18. And for the third, I got pi to the sixth over 3. And this would actually, or wait. Okay, my bad. Wait. Sorry, I'm getting confused with myself. Anyways, so then our final answer was negative 18 plus pi to the sixth over 3. So that is how I did standard 6B. Thank you.